Hello, Year 7, and welcome to Lesson 3 of this week, which is on melting and freezing. The first thing that you have to do, as per usual, is write down the title, please, and today's date, and underline both of those things lovely and neatly. Then I'd like you to listen up while I read out the learning objectives for today's lesson. We are going to recall the particle model that you learned in your previous lesson. We're going to describe the changes in particles when a substance freezes. We're going to define melting and freezing points and use data analysis. And we're going to identify some uses for melting and freezing points. You don't need to write those down, just need to be aware that that is what we are going to look at in today's lesson. Once you've written your title and your date, I would like you, as a starter, to list as many things that melt that you know. Can you get at least 5? Pause the video now, write down as many as you can. Okay, how did you do? What did you come up with? These were the 6 that I came up with. I thought about ice cream melts, makes a mess all over your hand sometimes, ice cubes, butter, if you are like a baker or a cook, you probably know about melting butter, chocolate, very fun to melt. Snowmen, not so fun when they melt, and metal as well. So when you are shaping metal, they have to melt it to make it form different shapes. Let me know the different things that you came up with. I hope you've got a really good list in your book, and you should have written those down. So here is our first main task today. We're going to recall the particle model. I would like you to do this by choosing your level of spice. If you're looking for a mild challenge today, you're going to go for green. In that case, I would like you to draw what the particles look like in a gas, a liquid, and a solid. If you can do this without looking back at your previous notes, that's even better. If you are looking for a medium challenge today, you're going to go for yellow. And you are going to use your words rather than a picture. You are going to describe the arrangement of particles in a gas, liquid, or solid. I want you to tell me, what do they look like? What kind of pattern are they in? Are they moving a lot or not a lot? I'd like you to use your words for that one. If you're looking for a real challenge and you're going for the orange, I'd like you to explain the arrangement of particles in a gas, liquid, or solid in terms of their energy levels. So for that one, you are sort of looking at doing the yellow challenge. You're using your words again, but when you're using your words, I want you to explain why they are in those formations in terms of how much energy they've got. Pick your spice, pause the video, have a go. Okay, if you drew your pictures of your solid, liquid, or gas, please check your drawings against these images that we've got here. If you are correct, your solid should look like this. It should be in a regular formation with the particles packed tightly close together and touching. The liquid ones should be an irregular formation. They are not in a pattern, but they are touching. You don't have any liquid particles floating up in the air. They are still touching and they're still taking the shape of the container there. The gas particles are moving around, they are bumping into each other. You might have drawn little movement lines on them, that's brilliant. So that is what your particle model should look like. If you went for the describing challenge and you're using your words, for the solid one, you probably said something like they are tightly packed. They are in a regular formation, or you might have said a pattern. They are vibrating. For a liquid, the particles are sliding over each other and they have more movement. And for a gas, they are moving freely. They are colliding with each other. They are moving more than the liquid. And if you challenge yourself to add in their energy levels, you should have also included that the solid particles have got the least energy. Liquid has got more energy and gas particles have got the most energy. They've got the most kinetic energy. They are moving around the most out of all the particles. If you did that, very, very well done. If you did any of those levels of that challenge, that's excellent. That's going to help you with the rest of the lesson. Now that we have remembered what the particles are like in those 3 states of matter, we're going to think about what happens when a substance goes from a liquid to a solid. In other words, when it freezes. So we know already that solid particles have got less energy than liquid particles. They are in a pattern, they are tight and compact, they're not moving very much, they're vibrating. With that in mind, can you read the sentences in the blue box and see if you can put them in the correct order by writing them down? The first and last one have already been done, they are already in the right order. So see if you can put the ones in the middle in the correct order. Pause the video now and have a go. Okay, how did you do? I'm going to read out the full answer. I want you to mark your own, please. So this first one was done for you. At room temperature, the particles in water have a lot of kinetic energy. Water particles can move past each other easily. When water is put into a freezer, the temperature of the water begins to drop. The water particles begin to have less kinetic energy. The temperature of the water reaches 0 degrees Celsius. The particles form an orderly pattern and can no longer move past each other. This means the water becomes solid and is now called ice. Give yourself a mark, but more importantly, I'd like you to correct if any are in the incorrect order, because these are going to be your notes to explain what happens when a substance freezes into a solid. So pause the video, check it, and correct it. Now that we understand what particles do when they freeze or when they melt, we can think about what melting and freezing points are. And something important to know is that different substances have got different melting points. They are going to melt at different temperatures. For example, water has got a melting and freezing point of 0 degrees Celsius. So when it gets cold, when it's winter, that's why the roads will freeze over. That's why we'll get snow, because it's cold enough for water to become solid. Do you know what the boiling point of water is? Think it to yourself, write it down. I'll tell you at the end of this. But very different to water, something like stainless steel has got a melting point of 1510 degrees Celsius. There is so much more energy that's needed for steel to melt. So you can tell a substance from its different melting points. If you don't know what it is, you could record the temperature at which it melts and find out what it is. Now, if you put that the boiling point of water is 100 degrees Celsius, you are awesome, very well done. Can you please write in your notes the highlighted sentences? Please write those down in your notes before you move on. So it's important to think about why knowing the melting and freezing and boiling points of substances are important. So I'd like you to just have a think to yourself. Why might it be important to know the melting points of different substances? Have a little think, jot some ideas down, pause the video for about 20 seconds, 30 seconds. So here are some points about why it is important. It's to know how to store a substance correctly. For example, if you want to keep water as ice in its solid form, you aren't going to keep it out in the room. You're going to have to put it in the freezer. And it's the same for certain chemicals. You might have to store them at certain temperatures. Melting points give information about the states of a substance at different temperatures. So you know that if you're in a very, very hot environment, certain substances are going to be liquids or gases. It may help to find out what an unknown substance is. So we know the melting point of water. If you have got a strange liquid and you freeze it and it turns solid at exactly 0 degrees Celsius, you know that that's water. It's also important because a substance that's pure, a single substance, has got a sharp melting point. It will melt at exactly that degree Celsius, but a material that's a mixture of substances doesn't. For example, butter melts very gradually. It's a mixture of substances, so you can tell that it's not pure. Have a little go at filling in these sentences. Pause the video fill in the gaps and then restart the video when you are ready to mark your work. The answers you should have, correct them if they are not quite there. The melting point is the temperature at which a substance changes from a solid to a liquid. The boiling point is the temperature at which a substance changes from a liquid to a gas. Water melts at 0 degrees Celsius and boils at 100 degrees Celsius. Well done if you got those right. Now, have a little go at these. I want you to tell me, what is the physical state of water at these temperatures? For example, is it a liquid, a solid, or a gas? Pause the video, have a look at the numbers on the left-hand side and write down if you think it is gas, liquid, or solid. Pause the video. How did you get on with the previous question? If you found it a little bit challenging, here is a way that you can think of it in order to make it slightly easier. You have got 3 states: solid, liquid, and gas. For water, we know that the melting point is at 0 degrees and the boiling point is at 100 degrees. So therefore, if we are looking at 45 degrees, which was our first question, 45 degrees is higher than 0 degrees. So it has gone from solid to liquid because it is past that 0 degrees. 45 degrees, is it more than 100 degrees? No, it's not. So it hasn't gone past the boiling point. So at 45 degrees, water is in its liquid form because it is between 0 and 100 degrees. Here's an example for water at 56 degrees. See if you can figure out if it's going to be gas, liquid, or solid. What about 125 degrees? Where is it going to land then? And what about -6 degrees? What about water at that temperature? Solid, liquid, or gas? What do you think? Now let's make things a little more challenging. Here are the melting and boiling points of some elements: chlorine, iodine, fluorine, and bromine. I'd like you to tell me, what state are they at 25 degrees Celsius? Copy out this table with all of the information and fill in the gaps, please. Remember to use the same process that you were using before. Where would they land? Would it be landing at solid, liquid, or gas? And write your answer in the right column. Pause the video while you have a go. And here are the answers. Chlorine would be a gas at 25 degrees. Iodine is a solid. Fluorine is a gas. And bromine is a liquid. Give yourself a mark out of 4 for those. And if you're up for the challenge, here's another lot, but this time we've dropped the temperature to -50 degrees. Have another go. See if you can get these ones. If you did particularly well on the last ones, I feel very confident that you will get these as well. Pause the video, have a go. And here are the answers with our decreased temperature at -50 degrees. Give yourself another mark out of 4. How did you do? If you got all 4 correct, very well done. Including the 4 before. I mean, that's just absolutely brilliant. Very, very well done. Congratulations, Year 7, you have reached the end of Lesson 3. Today you have recalled the particle model. You should be able to now describe the changes in particles when a substance freezes. You should be able to now define melting and freezing points and use some data analysis, which is what you were doing just then when you were deciding if something was a gas, liquid, or solid based on data. And you can now identify some uses for melting and freezing points, why it's important to know those things. You are absolutely brilliant. Very well done for logging on and completing your work from home. The last thing to do is now go onto Edulink and complete the worksheet that has also been posted there for you. Very well done.